Hi students, welcome to this GMAT practice session. Remember, in your busy schedule, to achieve your dream score, it's very important to take out a few minutes every day and practice mixed problems. So the strategy that we follow to achieve your dream score is twofold. The first step is structured preparation, and then the second step is mixed problem solving, and we will be focusing on mixed problem solving in this video. Do remember to take out every day a few minutes and practice random problems. Let's get started. In this video, we will be doing two things. The first part is that we will be solving three questions and they will be of the same type so that you will be able to solidify your learning of these type of questions. And if you get this question in the exam, you will be able to accurately and quickly solve it. And then in the end, we will quickly analyze the questions that we have seen and we will take a look at a few common traps and mistakes that students make. So let's get started with question 1. The first question is on your screen now. Try to solve this. Take out 1 minute and try to solve it. And then let's take a look at this question together. Alright, we are back. I hope you have given it a try. Now let's solve this question together. So we have a solar power plant and it's on for a certain number of hours every day. And it generates 480 megawatt hours of energy on a clear day and 360 megawatt hours on a cloudy day. If the plant generates 20 fewer megawatt hours per hour of sunlight on a cloudy day compared to a clear day, how many megawatt hours per hour of sunlight does the plant generate on a cloudy day? So that's the question. Now let's try to convert these words into some equations and things that we can work with. So we have two types of conditions over here. A day can be either clear or it can be cloudy. And then it's mentioned that the plant is on for a certain number of hours every day. All right, so let's assume that that's X hours, and on a clear day it's mentioned that the plant generates 480 megawatt hours of energy, and on a cloudy day it's just 360. Now what is the other information given? It's mentioned over here that if the plant generates 20 fewer megawatt hours per hour on a cloudy day compared to a clear day. So let's assume that in 1 hour on a clear day, the plant is able to produce Y megawatt hours of energy. Now, as per the condition in the question, on a cloudy day, it would be Y minus 20. And then we are asked to find this Y minus 20, right? So it's mentioned how many megawatt hours per hour of sunlight does the plant generate on a cloudy day, which is this Y minus 20. So that's what we need to find out. So we have successfully taken the information from the question and we have written it down in a way that we can use it to solve this question. Now let's proceed. Now over here it's mentioned that this 480 megawatt hours is produced in X hours, right? So I can say that in 1 hour on a clear day the plant would be producing 480 divided by X megawatt hours, right? That should be very straightforward, right? Because in X hours it's producing 480, so in 1 hour it would be 480 by X, and that's the same thing which is given as Y over here. So we can write that Y is equal to 480 by X, right? So why is that so? Over here you can see that Y is actually the megawatt hours per hour of sunlight on a clear day. So that's the same thing, right? So 480 by X is equal to Y. Now let's proceed and take a look at the conditions for a cloudy day. So on a cloudy day in X hours, the plant produces 360 megawatt hours. So in 1 hour, it would produce 360 divided by X megawatt hours. And that's the same thing as this Y minus 20, right? Because if this is Y minus 20 as per the information given in the question. So let's note that down. So Y minus 20 is equal to 360 divided by X. Now we have these two equations. We have two variables. We can easily solve it. So if I subtract these two, right, I can do that because you can see I can do that easily because the denominator over here is X. And over here as well is X. So if I subtract these two, Y minus 20 will give you 20, right? So let me just write that in case someone is confused. So Y minus 20. When you subtract that, this becomes Y minus Y plus 20 when you open the brackets, and you're left with 20, right? So the left hand side becomes 20, and then 480 by X minus 360 by X gives you 120 by X. Because the denominator is the same, you just need to subtract the numerators. So you get 120. And then the denominator itself is X. So 20 is equal to 120 divided by X. So that gives us X is equal to 6, right? So again, how is that? You just take this X over here and you bring the 20 down. So x becomes 120 divided by 20, and that simplifies to 6. Now if x is equal to 6, and again remember the question asks what is y minus 20, right? So you can see that y minus 20 is nothing but 360 by x. So let's substitute x as 6 over here. So 360 by 6 will give you 60, right? 360 divided by 6, that's equal to 60, and that is the answer to this question. All right, take a moment and quickly recollect and try to solidify in your mind what we just did to solve this question. So we had this piece of information in the question, and then we had this piece of information in the question, and then we linked these two together, right? We found that y is equal to 480 by x and y minus 20 is equal to 360 by x, and then we found x, and using x we found what is y minus 20, which is the answer. All right, now I hope you have got this question initially itself. In case you are not able to solve it, now you should be very thorough with these type of questions. Now it's going to add a lot of value for you if you go ahead and solve 2 more questions that use the same approach but which are worded differently and have different contexts, so that you solidify what you just now learned. And if you get this question on the exam, you will be able to solve it. So let's go ahead to question number 2. So you have question number 2 on the screen. Take a minute and try to solve this on your own, and then we'll take a look at it together. All right, we are back. I hope you have been able to solve this question. Now let's take a look at it together. So there is an electric train, and it can cover 720 miles on a full charge when running on an express route, and 600 miles on a full charge when running on a local route. So there are these two cases. There is the express route and there is the local route. If the train covers 10 fewer miles per hour of charge on the local route compared to the express route, how many miles per hour of charge does the train cover on the local route? Can you see that this is actually the same question as the question that we have solved before? It's just that the context is different, the numbers are different. So let's take a look. So it's mentioned that for full charge, it's over here, it can cover 720 miles, and over here it can cover 600 miles. So that's given in the question. Now let's say that on the express route it can cover x miles per hour. So as per the question, on the local route it can cover x minus 10 miles per hour of charge. So that's given over here, right? If the train covers 10 fewer miles per hour of charge on the local route, so if this is x, this would be x minus 10 miles per hour of charge. All right, and in the question we are asked to find this x minus 10, right? So that's what's mentioned in the question. Now let's proceed. Let's assume that this full charge over here is achieved by charging y hours. All right, now again we can try to link these two pieces of information, right? So if in y hours it was charged such that it can cover 720 miles, then in 1 hour it would of charging it would cover 720 divided by y, right? And that's the same thing as this x over here. So 720 divided by y is equal to x, and in a similar manner 600 divided by y is equal to x minus 10. Now let's try to solve it. So when we subtract these two, over here x minus 10 will give you 10, and over here 720 by y minus 600 by y will give you 120 by y. So we have 120 by y is equal to 10. Now let's go ahead and solve this. So y is equal to 12, right? We just need to take y over here, and 10 comes to the denominator. So 120 by 10 gives you 12. So y is equal to 12. Now if y is equal to 12, and remember we are trying to find x minus 10, that's equal to 600 divided by y. So 600 divided by 12, which is equal to 50, right? 600 divided by 12 is 50. Now again, just in case someone is facing difficulty in calculating this, from the table of 5, right, you will know that, or again you can take 60 by 12, or you can just do it by yourself also. If you don't know, if you divide this by 6, you will get 10 over here, and this will become 2, right? So this also cancels, and you are left with 5, and 5 into 10, there is a 0 over here. 5 into 10 gives you 50. So the correct answer to this question is option C, which is 50. Now take a moment and try to solidify what we just now did in your mind. All right, I hope you're very clear with this. Now to just make it absolutely sure that in case you get this question or a similar question in the exam, you will be able to accurately solve it. And remember, these are questions which are very similar to questions that you can find in the GMAT Advanced official book, and I've taken these questions and created these questions making them similar to the questions given over there. So there is a good chance that you get these type of questions. So solidify your learning. Now go ahead and solve this question number 3, and I am sure you will be able to solve it because it's very similar to the question that we have now solved. All right, so you have question number 3 on your screen. Pause the video and try to give it a shot, and then let's do it together. All right, I hope you have given it an attempt. Now let's try to solve this together. A spaceship can travel 528 light years per full tank of fuel in interstellar mode and 396 light years per full tank of fuel in planetary mode. So there are these two modes, interstellar mode and planetary mode. If the spaceship travels 8 fewer light years per unit of fuel in planetary mode than in interstellar mode, how many light years per unit of fuel does the spaceship travel in planetary mode? Can you see that this is actually very similar to the previous two questions that we have solved? So let's go ahead. So it's mentioned that in interstellar mode, the spaceship covers 528 light years per full tank. Let's assume that one full tank is X units. And it's mentioned that in interstellar mode and planetary mode, the difference is 8 light years per unit of fuel, right? So if in interstellar mode, it's traveling Y light years, then in planetary mode, the spaceship would travel Y minus 8 light years. Now, we can just go ahead and try to link these two pieces of information given. Now, if this is 528 and if it is X units, then in 1 unit, that would be 528 by X, which is what we have as Y over here. And in a similar manner, 396 by X will give you Y minus 8. Now, let's subtract these two equations. So over here, Y minus 8 will give you 8. And over here, 528 by X minus 396 by X will give you 132 by X, right? So you have 132 by X is equal to 8, and then solving for X, that's 132 divided by 8, right? So this is X. Now, remember, you don't need to go ahead and actually solve this. If in case you want to keep it as it is, you can do that as well, because we are asked to find only Y minus 8. Y minus 8 is equal to 396 by X. So instead of this X, let's substitute 132 by 8. So we will get 396 divided by 132 by 8. And in the denominator, when you have a fraction, this 132 remains over here and this 8 goes up, right? So that's how you simplify this. So 396 divided by 132 by 8 is equal to 396 by 132 into 8. And when you simplify this, you will get 24, right? Let's try to do that. You can see that this 396 by 132, this goes actually 3 times, right? Just multiply this by 3, you will see that you will get 396. So this over here becomes 3, and 3 into 8 is 24. That is your answer. Now I'm sure that you have thoroughly learned this type of a question. Remember to revise this. Now let's also take a look at the pattern, and let's revise it probably together. Now, what kind of a question is this? Let's just take a step back and think about the 3 questions that we have seen, and let's just think what type of a question was this. Now, let me just frame a question on the fly to explain to you what type of a question this was. Let's say there are these 2 countries, country 1 and country 2. Now, let's say that for Y dollars in country 1, you can get A mangoes. Okay, let's say that this is mangoes, okay? And in country 2, you can get B mangoes for Y dollars. Okay. Now, it's also in the questions, you can see that the information 1 is stated in this form. And then you have some other information which says that per dollar in country 1, you can get X mangoes. And in country 2, you can get X minus 2 mangoes. Now, because I've phrased it as mangoes, this seems like very easy, right? This seems very easy. But in the questions, it's more like distance per unit of time or something like that. But it's just the same thing. Now you can see that over here, the relation between these two is that A divided by Y will give you how many mangoes can be bought for $1 in country 1, which is the same information given as X over here. Similarly, over here, B divided by Y gives you the number of mangoes that you can buy in country 2, which is the same information which is given over here as X minus 2. And the added information is that it's given in the question that the difference between these two is 2. So if you subtract them, that is A by Y minus B by Y, that's equal to X minus X minus 2, which is equal to 2. And then you can form the equation, and then you can go ahead and solve the question. Now, many students may find it difficult to form this equation. Now, with this video, your learning should be thorough, that if you see a similar question or something that uses this type of a principle for forming the question, you will be able to form this equation. All right. And many other students also make a mistake, which is a trap actually, is that the question asks you x minus 2, and you will see that invariably one of the answer options would be x. So in a hurry, a lot of students go ahead and mark the value as x, which is wrong, right? So carefully reading the question will help you avoid this trap as well. All the best in your preparation, and do remember to subscribe to this channel, like this video if you want more content from me, which helps you to quickly practice a few questions in the midst of your busy work schedule. And also leave your comments below and let me know what you think about this video, or if you have any doubts, or if you want to get some more videos of a particular type, etc. Do let me know in the comments. All the best in your preparation, and all the best in achieving your dream GMAT score.